All right, so we need to talk about trig identities. So,
I remember those.
nice. Which one do you remember?
I remember one that we already went over, that sine squared plus cosine squared equals 1.
Okay, this is the one I fundamentally care about you guys knowing.
Oh yeah, sine squared theta plus cosine squared theta equals 1. That's a really important one. My trig teacher said that that's pretty much all you need to remember.
Yeah, so I would claim you need
Yeah, you can derive the rest from it.
you need 2.
Okay, the other one that you need.
You need this one, and you need the half angle identity, which seems like a totally freaking useless thing to know. Right? Because it's not useful for like surveying, it's not useful for figuring out stuff about angles in your house. It is super useful for doing calculus with trigonometry.
Sine squared theta plus cosine squared theta minus.
Do you guys know that half angle?
Nope.
Probably not.
No.
Is the half angle? Is there something with like sine, cosine, cosine, sine? So it's like sine.
I'm not gonna try to
embarrass myself. Minus cosine squared theta.
Saying that's
Something like.
Let me go get it, because I oftentimes have trouble remembering the thing too.
Yeah.
So let me show you where you go fetch this thing from.
Sine.
Okay. So
Whoa, that's a big circle.
I'm going to draw, actually, I'm going to even slim this down a little
Oh,
bit.
come on, that was perfect.
That was nice, but not perfect. And also, I only need a quarter of it anyway.
Wow. Very big circle.
Okay, so I hope you'll all take note of the fact that I needed a giant circle for this. Okay,
Wow.
so in my giant circle, I'm going to put 2 angles. I'm going to put an angle here that I'm going to call,
Hopefully theta.
so I'm going to try to keep the letters from being super scary. I'm going to call this angle theta, but I need your second favorite choice of angle too.
Z.
Q.
So cosine theta equals 2 cosine squared. 1/2 theta.
Okay, cool. I'm going to use this thing.
I don't know if I know.
Anybody know what this thing's name is?
No,
Zero.
but I keep seeing it in the
Seven,
book.
nothing in it.
Okay, cancel. No, no.
Oh, there's a difference.
Isn't it?
Yes, there's a difference.
Okay, that would've
So this is a theta, and this thing is a phi.
been- Oh, I
Phi. P-H-I.
What's the problem?
Five.
Phi?
thought.
Phi.
No.
Thesis.
You don't want to say thesis.
Okay. Anyway, point is, I have 2 angles, theta and phi, right? And what my interest is going to be is in developing formulas for sine and cosine of the sum of the 2. You guys see that? So this whole angle here, right? This whole angle is, that's theta plus phi, right?
Yeah.
So that whole angle in there is this theta plus phi thing. And my goal is going to be to figure out a formula for sine of theta plus phi and a formula for cosine of theta plus phi.
Okay, so sine of theta plus phi equals.
Okay,
sine
so,
of theta plus cosine of theta.
Okay,
Plus sine of phi plus cosine of phi.
stop listing the identity.
Oh, that was right.
But yeah, if you memorize this thing, that's great. I would encourage you to actually just memorize these 2, because you can get everything else you need from those 2. If you have to go through the picture every time, it just takes forever. Okay, but I'm going to go through the picture once so you guys have seen the picture at least once. Cool? So here I'm going to drop a vertical. You guys with me on that?
Yeah.
Okay. What's that thing going to be about?
That is the sine of
That's the sine of theta plus.
Oh, I'm sorry. I see. Yeah.
You guys see that?
Do it again?
So this whole distance, right?
Yeah.
Because this whole angle's theta plus phi. That whole distance is the vertical side for theta plus phi.
Yeah.
Right? So that whole thing
Is sine
is sine
of theta.
of theta plus phi. You guys with me on that? Where's cosine of theta plus phi?
It's the distance between the origin and where it meets the x-axis.
Yeah, that should be this guy here. You guys all with that?
And that's cosine of.
That's cosine of theta plus phi. Guys cool with that? Okay, so now I need some bits and bobs. So my claim is that we should know what this side is.
That's sine of theta.
Let me just keep my labels as clean as I can. That side should be sine of theta.
Cosine of theta.
And then this whole distance here
Cosine of theta.
is cosine of theta.
Okay.
You guys all with that?
Yes.
Okay.
I wish I drew a picture.
What?
That's just remarkable.
All right. So now I need a guy like.
Ew.
You guys see what I'm gonna try to do here?
How to do the sine of phi.
So my goal here, right, is to draw a sine of phi, right?
Yeah.
Okay, so to get that right, I'm gonna need you guys to tell me when I'm perpendicular to this line here,
To which line?
to this one.
That was pretty good.
Yeah.
Is that pretty perpendicular?
Yeah.
Yeah.
That's perpendicular.
Okay, so
That's probably the straightest line in the entire picture.
it is definitely the straightest line in the entire picture by quite a bit. You guys with me on this?
Yeah.
Okay, so what are those two sides?
Well, what's the sine?
That's sine of,
What's
Cosine and sine.
Yeah, those are sine and cosine of phi, right? So this whole dude here
Sine of phi.
is sine of phi, right?
yeah,
And this guy here,
cosine of phi.
this distance is cosine of phi. You guys with me on that?
Yeah.
Okay. Now we're gonna make this even worse. You guys ready for this?
Pretty bad.
I know, it's pretty bad. Okay.
Ah.
That's not.
That's
not
definitely
good.
not.
Are you trying to get it parallel to the bottom?
I'm trying to get it perpendicular to this thing.
It is now.
That's
That-
about
that
right.
is now.
That's about right.
Oh.
Oh god! Oh no, I moved it!
Oh no.
Oh, it still looks badass.
Then you ruined it with that extra little line. It would have been better without it.
Oh my god, it's not working.
That's worse.
Should I keep drawing on it to fix
Just
it?
make it like an inch thick.
Just put the box in the corner. It's perfect.
Okay.
Okay. Alright, and then I got this piece here.
Okay.
I don't have.
That would be.
I know.
Oh my
I
god.
was
What?
trying to-
Yeah, don't try to draw this picture, okay? Like just play with me up here. Just play with me up here and
I'm
we'll
definitely drawing this.
Well, I waited.
Don't
Just
just
committed now.
But I'm
I've already
not
drawn too
smart.
much
Okay.
to turn back.
I'm just so committed. Okay,
Should
so
start over and draw on that
now
entire page.
I'm gonna start yanking some pieces out of this, right? But the first one I wanna get is this piece right here.
There's a square in there. Right?
There's a square in where?
In there.
Oh yeah, this thing's a square. You guys see that?
That will always be a square regardless of.
Yeah, and the reason that's a square is I kind of forced it to be a square. You guys all see that? Because I made this line here parallel to the x-axis,
Yeah.
and I made these two lines here parallel to the y-axis.
Yeah.
Okay, it's not necessarily a square, but it's definitely a rectangle.
So
In
if you
theory.
were,
And I'm only going to use that it's a rectangle. I'm not going to use that it's a square.
so if you decreased phi a little bit.
Yep, so if I decrease phi a little bit, then this thing would get a little longer.
Would it?
Yeah, but it would still be a rectangle at least. You guys with me? Okay, so first things first, I want this vertical distance here because that's part of sine of phi plus theta. You guys all see that? Like if I knew this part here, I'd know at least some of sine of phi plus theta because it's this part here plus that part there.
Yeah.
That's sine of theta minus cosine of theta? No.
Okay, let me pull that triangle up.
Wait, though, which one are you trying to do?
I'm trying to do this part here.
Yeah.
So I'm going to take this whole triangle,
Yeah.
and I'm going to pull it out over here. So
Oh, snap. Okay.
this triangle, I'm going to yank out, and I'm going to draw it over here.
Okay. I feel you.
Good with that?
Yeah.
Okay, what's the angle in that triangle?
That's theta.
Okay, that one has a theta in it. Okay, what's the hypotenuse on that one?
Cosine of theta.
Cosine.
No, because it's not the full cosine
cosine.
of all of it.
Oh, it's cosine of
Cosine.
theta and phi.
It's
No, it's
phi.
phi.
It's just
That's
cosine
phi.
of
That's
phi.
a phi.
I thought that was a
But
theta.
it's not,
Sorry.
it's not all of cosine of theta.
No, it is all cosine.
No, it is exactly all of cosine of phi, because that's how I made it.
I see.
Right, I took a line that was parallel to the x-axis, and I put it from the sine of theta plus phi line
I got you.
over into that corner. So I forced that. You guys see that?
Cool.
Okay. So, and then the bottom there isn't cosine of
It's
theta
cosine
because
of
that's
theta
too
plus
long,
phi.
right? That cosine of theta is the whole bottom.
Yeah.
But it's
But
too short if it's just cosine of theta.
Yeah, so I know it's definitely shorter than cosine of theta.
So do we have to find?
Okay, so what I need to know is this guy's an adjacent side, right?
Sine of
Yeah.
theta over-
So cosine of theta should be that adjacent side divided by
the hypotenuse.
Cosine.
the hypotenuse, which is cosine of phi.
So cosine of phi
So A is cosine of theta
times cosine,
times cosine of phi.
and that's just that.
You all with that?
Yeah.
Okay, so this part here is cosine theta cosine phi.
So then,
Okay, so in the interest of clarity, I'm going to leave most of my rectangles labeled over there. What's the vertical part?
that's just.
That's what we're trying to do. That's
Yeah, that was the one I was trying to figure out
That's
anyway,
sine
right?
of theta equals whatever you get cosine of theta.
So sine of theta should be this side over the hypotenuse.
Right.
Yeah.
So this guy is the sine times
A over cos phi.
this times cosine phi.
Oh, yeah, well, you do that.
You guys see that?
Yeah.
Right.
That's just, if you want to get to opposite sides, you take the sine and then multiply by the radius. It's cool with this?
Mhm.
Oh, and it should be noted that that was a right triangle so that it's valid to actually do trig in there. Guys good on that one?
Yeah.
Okay, now for my next trick, I need to pull out the other triangle.
Which
Big-
one?
the big
There's
ones.
like
There's a lot
of
six-
them.
there's
There's
like
a lot of
Is it the one with
triangles.
with the angle you've already indicated? Yeah. that one.
That's the one I need.
Alright.
See this little dude? Why do I need that one?
Because then,
Provides the rest of the sine of theta plus.
Yeah, because if I want cosine, right, I could think about cosine of the sum, right, is go out to here and then come back. I know the out to there already, and then the come back, I'll use this one. You see that? And then if I want the vertical part, right, I could think the vertical part is go up this, which is the vertical over there, and then up this, which is the long side on this one.
Yeah.
You guys with me? Okay, so I need to pull that triangle out. And then I need to figure out what the hell I know about it.
We know the hypotenuse is sine of phi.
Perfect. I know the hypotenuse is sine of phi.
That's about it.
And that's about freaking it, right?
That means we can-
That feels like about it. I gotta find something about an angle in here though.
you know that the long side is sine of theta plus phi.
Oh, you know that the
Sine would be
It-
cosine
the bottom
of
is-
theta minus.
Okay, so find me one of these two angles. That's what I
you
need.
have with a 90 degree and you have.
I need one of these two guys. I have
16,
one
30.
90-degree angle. I know that already.
It's a 30, 60, 90.
No, it's not a standard triangle. It's got something to do with theta or phi. We need to figure out what.
Wouldn't it have to do with phi, considering where it's falling?
Yeah, it probably has more to do with phi, right?
So we can figure out the top angle.
You guys
of
see that?
the triangle, 90 minus phi.
Okay, so
90 minus.
you guys want to notice a weird thing?
Oh, it's half of the. No, it's
Cosine of theta is at the bottom, so isn't it the same as the top?
Can't you get the small leg?
So
Let's see. So what's this angle here?
It's the same as theta.
it's
Why is it the same as theta?
because it's a parallel cut by
It's
transversal.
parallel,
It's on the
yeah.
opposite
Yeah,
side.
it's an opposite interior angle, right?
90
So that one's a theta. So this angle in here
minus
is
90 minus theta.
90 minus theta, or pi over 2 minus theta.
Right.
And then they need to add up to 180 degrees,
So
right?
the top one is.
So 180 minus 90 minus theta.
So 180 minus 180 minus theta.
No, 180 minus
No.
90 minus theta.
So I think that should be 180 minus 90 minus the quantity 90 minus theta,
Yeah, that sounds about
right? Which
right.
is
So minus 90 minus 90.
theta,
It's just theta.
because that's how much you're short by, right?
Yeah.
Right, like you had 90 and then you had
Oh, I
90
see
short
what you're-
theta,
Yeah, yes.
so you're short by theta.
Yeah, that was silly. Yeah.
So this angle up here is theta. You guys see that?
Yeah.
I was expecting a phi up there, right?
It's funny.
But somehow it was a theta? That feels weird. Okay, so what do you know about this guy?
Cosine.
That is going to be.
Sine theta.
Oh yeah, that's related to sine of theta, right? Because it's opposite.
Yeah, so it's
Sine
So that should be sine theta
times
Times
sine
sine of
of
times sine of phi, right? Because sine of phi is the radius here.
yeah.
And then this vertical guy
cosine of theta times sine of phi.
is cosine of theta times cosine
Nice writing.
of phi.
Wait, why is it times cosine of phi?
Sine.
Oh!
Yeah, it'd be, yeah.
Obviously it's sine of phi. Thanks.
How are you writing
I'm gonna
like
name
that?
the first child Sine.
How are you writing vertically?
Wait, that's actually not.
Practice.
Tons of practice. In the flipped classroom, I write upside down. Because I sit across from someone and help them with their work, so I write upside down on my paper. So when you learn to write upside down, writing sideways is no big deal.
Jesus Christ.
You can write left-handed. I told you you could. Just try. 5 hours. You got 5 hours. What are you going to do with your time? Spend it sleeping or something?
Oh yeah.
Who sleeps?
Okay, anyway, point was, I think I need to figure out what sine of theta plus phi was. Which bit was that?
The sine of theta plus phi.
Yeah, that was the big long vertical part, right?
Yeah.
Which is made out of
Oh, we have it now. It's
that
cosine
stuff, right?
theta plus sine-
And this is part of that stuff,
and that.
and so is that one.
We just add those
So it's
together.
cosine
And those need to be
theta
added
times
together.
sine phi plus sine theta times cosine phi. Yeah, this is what I was trying to say.
This is so weird.
No, it makes sense.
So you just drew this picture to help us, like, to prove
To
that
prove it,
this-
yeah.
Yeah, I'm showing you where
He
those
found the
identities
origin,
came
yeah.
from.
Just like he originated.
Okay, cool, yes?
So
Yeah,
what-
yeah, we all agree.
Yes?
Yeah.
So, how do you remember this identity?
Cosine sine, cosine sine.
It's cosine sine, added together, and you just switch the angles.
Yeah.
Right, so you do cosine of one, then cosine of the other, sine of the other one, and sine of its opposite.
Yeah.
You guys cool with that?
Yeah.
And you're adding in this one.
Yeah.
Now, in the other one, the other one's weirder,
You subtract.
because you have to go out and then back, right? So we're going to go out by this side, so out by that side, and then back by
Sine of theta, sine of phi.
this guy, the sine. So you're going out by cosines, back by sines. So you do
Oh.
cosine of theta, cosine of phi,
Cosine, cosine.
minus
Sine of theta times
sine of theta, sine of phi.
I
So
remember
cosine,
that.
sine, minus
Cool.
in the middle, 'cause you know what will-
Oh, so these are the angles.
So these are the sum of angles identities.
Yep.
So my claim is that you will need 3 identities. You need the Pythagorean identity, the sum of angles identities, of which there are 2,
And then half of them.
and the half angle identities. You do not need to know the doubles.
That's cool.
And I'll show you the half angles next time. Cool?
Cool.